Okay, so in this problem here, we're looking for the domain and the range of the inverse. So in order to do it, I'm going to look at the domain and the range of the original function. And so when I consider, I know the domain of the original function goes from -6 all the way to positive infinity. I'm going to write it as in this kind of notation. It's actually, so -6 to positive infinity. I want to find the range of the original function. So I take my -6, I plug it in. 5 minus 1/3 times -6 ends up being 7. When I plug in 3, 5 minus 1/3 and 3, that ends up being 4. When I go to the second piece of the function, I plug in the 3, I get -2 times 3 plus 10 is also equal to 4. And if I pick some large positive value, let's say like x equal to 100, I get a sense, I know this is a line, so it's going to be getting more and more negative because that's 190. So the range actually is going to go from -infinity all the way up to 7. And so now here's the cool thing about original functions and inverses. The x and y switch, but also the domains and ranges switch. So the range of the original function is the domain of the inverse. And the domain of the original is the range of the inverse. And so if I take that negative, so I could also write that as x is less than or equal to 7 is what this says. And this one here says y is bigger than or equal to -6. Okay, so in this problem here, we are looking for the dimension of the rectangular area so that the swimming pool is between, as an area greater than 6. So we're looking for area. And so I know that area is going to be 7 minus x times x plus 2. This is my area function. And I want the area to be bigger than or equal to 16. And so in order to do that, what I'm going to do, if I graph it, I can see when I graph it, here is my top function, and these values here are exactly where I'm looking for here. Anything in here, so anywhere where my x value is between 4.56 and 0.438. If my x value is in this range, then I know the area is going to be larger than 16. And with these x values, you can find the actual dimensions of this thing here.